Good afternoon and welcome. I'm Michael Wislam from Bristol Composites Institute, and we'll be starting in a few minutes this session of Sustainable Composites, the Future. Just waiting for a few more people to join, and we'll be starting shortly. Thank you. Okay, so welcome again to this session of the Sustainable Composites Summit. Some of you may have been following this for the last couple of days. And for those of you who may have missed that, it was recorded and is available on YouTube. And some of you may be joining us for the first time, and you're all very welcome. So this event is a joint event between two of University of Bristol's institutes, the Bristol Composites Institute and the Cabot Institute for the Environment, in collaboration with the National Composites Centre. It's a very exciting time, I think, for sustainable composites, and we believe that they have a key role to play in lightweighting and in reducing global emissions. But they also have their own issues, which I think it's very important to recognise and to understand and identify how we can address them. So in our preamble for our speakers, we've asked three key questions to be addressed. And also I'd like to encourage everybody who's participating in this to think about these questions as well. How can composite materials help us to achieve a net zero carbon world? How can we innovate to ensure valuable composites are recycled and reused? And what are the emerging opportunities to improve the social, environmental, and economic sustainability of the industry? We'd originally planned this as a live event, face-to-face, but in the circumstances we've moved to having it online, and that's had many positive aspects because we've got a large number of people being able to attend who perhaps might otherwise not have been able to attend, and we saved a huge amount of CO2 in not having to travel. So that was a benefit. We're hoping everything works well with the technology, but we keep our fingers crossed. Do bear with us if there are any problems. So today's session is on sustainable manufacturing of composites. We've got 2 hours with 4 excellent speakers. There will be an opportunity to ask questions following each of the speakers, and then we'll have a panel Q&A at the end of the session. So please use the Q&A function in Zoom to ask your questions. I'll be keeping an eye on that, and then I will ask the questions on your behalf. Also, please note you are able to upvote the questions, and the ones with the most votes will be at the top of the list and will therefore be at my attention to answer in priority. Right, so without any further ado, I'd like to introduce our first speaker, which is Dr. Tim Young. Tim is head of materials at the National Composites Centre, which is one of the 7 centres of the High Value Manufacturing Catapult Centre. Tim has an engineering doctorate from the University of Surrey, and he worked at National Physical Laboratories before coming to NCC. And he's played a leading role in the Rediscover project, which is one of the activities of the High Value Manufacturing Catapult. And he's now going to tell us a bit more about the activities of the High Value Manufacturing Catapult and our green future. So Tim, if you'd like to share your screen.
So, hello everybody. Hopefully you can see that. So good afternoon is probably the best thing to say, and good morning for those who are arriving from the States. So my name's Tim Young. I'm absolutely delighted to be able to give an update on the HVMC and green growth. As you can see from the title page, though, one of the key commitments with the HVMC is sustainability. It's recognised by the partnership between the NCC and CPI, but I'll come on to that later. I can't claim to have led everything. I was definitely part of Rediscover. We will hear a lot more about that tomorrow. I'll give a bit of an introduction and hopefully be able to answer some of those questions that Michael spoke about at the beginning. So first of all, if I can get the next, there we go. So it's kindly introduced yesterday by Professor Mark Gillen. The HVMC consists of 7 centres shown on the map. As a collection, it's actually one of the largest manufacturing RTOs in Europe, covers key areas of excellence that underpin and support the UK competitiveness through a comprehensive set of industrial sectors and technologies. I work for the National Composites Centre, but composite material capabilities exist at multiple sites, from the National Formulation Centre at the CPI through to AMRC, WMG, MTC and AFRC. And obviously within those dedicated National Composites Centre facilities. Collectively, the capabilities allow us to work together to support and lead some of the manufacturing elements of key strategic visions in the UK. And the most pressing of these is global circular economy. In this context, sustainable composites. It won't have escaped your notice that sustainability has become a priority. There's a huge drive for genuine change, both from a moral standpoint, sustainable champions, Extinction Rebellion, but also a legislative standpoint. We've got net zero legislation now with huge weight behind it. It's legal, it's written into what we're going to do. But the fact is, it's not going to go anywhere. We might deliver net zero. Are we going to do it in the right way? So it's recognised by the call to ensure economic growth does so in a sustainable manner. And we know that previous talks, there are areas of success, but also massive improvement that the composites industry needs to do. And there's going to be a lot more pushback, challenges on using composite material at the end of life planning. So we're at a crossroads. We have an opportunity to respond to today's economic recovery demand whilst ensuring we do so in a responsible manner and picking one of the key impending targets. How can we enable a sustainable transition towards a sustainable UK economy that also meets net zero by 2040? And where on earth do composites fit in this? So composite materials enable us to have lighter, longer structures such as wind turbines, more durable structures for construction and energy. We have lightweight transportation for reduced fuel burn and many more advantages. But we know that it isn't enough. From the talks yesterday, great presentations on possible improvements in biomaterials to reduce feedstock dependency, great introduction from Steve Pickering on some of the energy and end-of-life research. Composites can enable green economic growth, but we need to ensure that we do so sustainably and develop the solutions, the designs that tackle the before, that feedstock problem, and that afterwards. We don't want to be in a situation of achieving carbon net zero by 2040 and still have 98% of matrix materials derived from petroleum, or still be landfilling 110,000 tons, unless we're doing it in absolutely the right way and knowingly that that is the best solution. So who else is actually calling for action? Well, over the last couple of years, 2 reports have been in development, both published in 2019. The first, the NPL report, National Physical Laboratory, enhancing UK competitiveness by increasing UK competitiveness by enhancing the composite materials regulatory infrastructure. We've also got the Vision and Roadmap for Sustainable Composites, published by the Composites UK. And there's a widely accepted need between industry and academia that radical transitions are needed. I've spoken the last slide about changes to the end of life and feedstocks, but also required from these reports are tool sets providing confidence, design for sustainability, qualification support, and many more things. But what actually remains is a mechanism to deliver, funding to support it, a willingness to collaborate that doesn't just ensure the output becomes siloed with little effect. So we've created a model at the NCC and used now very much so within the HVMC to describe the composite material supply chain. And there are 4 elements to this. I'm referring to the infinity loop on the left with the tails. We have the feedstock input, we have chemistry, formulation and design, we have a manufacture and service life, and then various different end-of-life loops or exits. And we recognise that National Composites Centre is only part of this puzzle. The HVMC capabilities I mentioned are another, but there's a wealth of academic and industrial know-how. The image on the right-hand side is a simplistic model of the offset technology readiness scale. It represents how chemistry on one side and the application of composites, there's actually significantly different languages or expectations. And if you just take material science, you can have a composite material developed at TRL7 that might be ready for sale under chemical companies or suppliers, but actually some of the processing or some of the application is still relatively immature at TRL4. And there's barriers even within just two areas that we need to go past. And what we've, NCC and CPI have committed to supporting each other to complement capabilities on behalf of the HVMC, better engage with academia, being able to pull through ideas with the benefit of industry. But we've got a challenge. How can we actually support such a complex supply chain with a multitude of academic research institutes, end users, different technology readiness levels? And the answer is quite simple. It's just down to collaboration and partnering. CPI have got a significant strength in the chemistry formulation across the supply chain, touched on it a minute ago, but we've agreed together to lead on behalf of the HVMC action towards fully sustainable composites. And what we hope, considering the statement about collaboration, is to inspire similar action across academia and industry to work together, form new partnerships and transform the beginning and end of life from what we hope to be a challenge to a success story. But what have we already been doing? So just some examples from the NCC, and these are a snapshot. We've been working with industry support, particularly over the last few years, seen a massive increase in appetite from our customer base and those that we work with to do projects that really embody sustainability. We've developed some technology, example here, Oxford Brookes, around end of life. Lucy Eggleston speaking tomorrow will talk a bit more about that. We've also started in developing new processes for sustainable products. We've created new networks. I will touch on the Rediscover program, which you can see the logo for. We work with academics already, some great work being housed at the NCC, but very much from the University of Bristol around the hyperdiff process. And you'll hear more from Ian Hamilton later on that. We work with recycling, reprocessing, answering questions like how many times can you reprocess PEEK and what is the degradation that happens over the course of its life. We've made biodemonstrators to try and attract appetite from customers. And we've got a business-wide commitment to sustainability. So just mapping out where we sit, going through ISO accreditation for environmental management, and actually transforming our waste management systems. And underpinning pretty much everything we do is a vast capability at the NCC, looking at life cycle assessment. How do you design so that we don't just design products based on performance and cost, but we include the impact? How can we measure it? What work do we need to do? Who do we need to partner with just to try and get those valuable data sets out? Try and support some of the questions from the last few days about carbon data. How can we try and unlock and support that? So those are the things that we've been doing. One of the things particular is Rediscover. This is across HVMC. It is a great collaboration between the various different 7 centres where we identified a shortcoming, we identified a problem that needed to be solved. And in this case, it was recycling, disassembly, circular materials or more sustainable ones, and how do you reuse? We collaborated, we built an industrial community of like-minded and invested academics, industry who really wanted to make a difference. The output of the programme that ran last year, and you will hear a bit more about what we're doing and how to get properly involved in what the next steps on Rediscover from Lucy's talk tomorrow, but it was a huge network and consortium. We understood the real gaps and we have a focus to build on this and to make some changes. Oh, excuse me, I have jumped ahead. So where we are today, I've covered some of the work we've done, the call to arms that we've seen in various different workshops, the roadmaps, the network, engagement within industry and academia, but we have a challenge. How can we continue the momentum and ensure that we deliver? I've touched a couple of times the agreement between CPI and NCC. You'll hear more about the launch projects, the activities tomorrow. But for now, I'd like to play an introductory video on what we mean as sustainable composites. We'd welcome feedback on it, and we'd encourage you to tell people about it if it helps you to describe both the positives and the opportunities that we have as a community. So to summarize, and thank you for letting me speak today and introduce what we're doing. Composites materials have a significant role to play, and we want to reach net carbon zero by 2040 in the right way. So look forward to hearing any questions that anybody's got. Thank you very much for your time, and I look forward to hearing some of the other presentations later today. Thank you.
Thank you very much, Tim. So we have a few questions, and if there is more, please continue to put them on the Q&A. So first off, what is being looked at with regards to consumables such as bagging films and breather cloth in composites? There seems to be no widely used solution to recycling these materials.
That's a good question. So I can think of two things that we've been doing at the NCC of late, one of which is to look at reusable bagging films. So particularly things like silicone, how do we do that? We've been working with a supplier, and I will try for the information later, find out exactly who that is. The aim for that is if you can sustainably reuse it without having more material to end up scrapping at the end, then that would be one thing. The second actually is a real challenge internally when we're doing R&D projects. We have to use a considerable amount of bagging and breather film, which often are one-offs because we're only going to make one component. And that at the moment is a challenge that eludes the most. We've gone through waste management processes. We've been looking at how do we recycle all of our materials. Bagging films and breather is one of the hardest at the moment. We have kickstarted a few small projects to look at this. There aren't any quick solutions just of yet. If people do have, I would be very interested in hearing them.
Yes, I think with all of these things, we can turn it round to the audience. If you have ideas, please, you can contribute them, and we look forward to picking up some of those as well. So, next question here. Have you considered partnerships with universities or companies outside of the UK, for example, Germany?
The short answer is yes. So the intention for what we're doing is to kickstart something. The first instance is to make sure that we actually have a good delivery mechanism, and we can try and build on that. It's very much, we're looking currently at some bid opportunities and how we work with Europe. I would say we'd quite like to go outside that as well. So we're not going to be able to achieve this if we are just focused on the UK. We have to look globally.
Thank you. Do you have any plans to develop a natural fibre composite?
Just thinking about the context for it, in terms of, are we going to develop and sell? No, because we want to support UK industry, not compete with it. That's our aim. We do have plans currently to try and run a project. You'll hear, hopefully, I think it's one of the projects Lucy might be talking about tomorrow, about one of our launch projects looking at showcasing what you can actually do with bio composites. We're not going to start manufacturing and compete with industry though. So if there are biocomposites that want to be showcased, that's what we're here for, is to try and support that and help develop the applications and give confidence in their use.
Thank you. For truly sustainable composites in terms of reuse, do we not need to move away from thermoset to thermoplastic composites? And to what extent do you think this transition is feasible?
Ooh, that's a very good question. Interestingly, my first project at the NCC was looking at that exact transition. I spent a year just focused on one particular application. It varies between product by product. Thermoplastics have significant advantages, but so do thermosets. And I think it's a yes and no answer, unfortunately. I can see a time where the toughness of thermoplastics and the opportunities to repurpose, reuse, reform, all of those things become a significant advantage. And we are seeing great developments in the use of PEEK, particularly as aerospace material and subsea. So I think there are big opportunities, but as discussed in the previous presentations, it may be that we want to look at the thermoset durability and keep things in service much, much longer.
Thank you. So we still have a few more minutes for questions. So if anybody else has got other ones, please feed them in on the Q&A. Meanwhile, perhaps I can ask you something, Tim, about how best do you think we can get universities, catapult centres and industry working together to make this this vision, to achieve that vision?
I think having spent the last year getting to a point where language is common between CPI and the NCC, and we build trust and actually end up being able to do projects. I think those are some key issues. I think we in order to be sustainable, we have to be willing to work with different people, different consortium, and try and build trust. I think the drivers are so very different from how they used to be in the past. Having big networks is helpful, but part of the risk that we're taking by doing the partnership is to try and get on and do something. And it's required internal investment on the risk that we need to find a way of ensuring its longevity. We need action, we need the funding bodies to get behind academics to fund it. We need the industry to support it, letters of support, that kind of thing. But ultimately, we need to build trust.
Question from Stella Job here. What is NCC doing to develop LCA capability?
Well, great question. We have a number of different things. So we have an entire team developing sustainable composite capabilities, and core to it is LCA. We have a PhD program at the moment looking into data, particularly carbon fibre data. We've also invested in mapping out our own NCC manufacturing processes in the way of life cycle assessment. So the gate-to-gate aspect of manufacturing can be better unlocked and remove some of the assumptions in an LCA. Also help advise industry on which process might actually unlock a much more sustainable product. That's allowed us to really work with industry to develop some of the LCA sides around their products and help them make better decisions, sometimes surprising ones. And the other side is really partnering. So how do we work with companies and trade bodies and who are also involved in LCA?
Thank you. Question here from Fanrang Meng. Wind turbine blade wastes are mostly made of glass fibre, not carbon fibre currently. What would you see the future waste treatment strategies considering the low value of glass fibre? There seems no financial viable or even environmental viable solution for these GFP, so landfill seems to be the best option now.
Yeah, that is a significant challenge. I'm trying to think how best to answer it. We have a project which Lucy will be talking about tomorrow, specifically looking at recovery and how do we build that value. So I'd like not to answer it, but instead say, if you really are interested, come and listen to her talk tomorrow.
Excellent, good plug for tomorrow. Question from Dr. Hopwood. Many of the recent sustainability-based funding calls focused on consumer plastics and composite materials have not been in scope. How confident are you that Rediscover will receive the funding it needs?
I wouldn't say, I think confidence is the wrong word. I think we have to drive it. So if you genuinely believe it's needed, then we need to be getting behind initiatives like this. We need to be working in the workshops on Friday, making sure that you put your 2 pence into the papers that will be generated by the University of Bristol, and continue lobbying with government. We're going to put a lot of work into publicising it to try and make sure that the case is clearly heard. I would welcome support in that. We are looking for engagement with industry. In terms of funding, we're doing what we can to work with the various different funding bodies. You've heard already from earlier in the week, Innovate, I believe EPSRC is speaking on Friday. And we've had a minister, so it's raising its profile already. And I'm more confident today than I was yesterday.
And Mark Gillen yesterday, Chief Technology Officer for Innovate UK, did call attention to the call which just went out a day ago, which focuses on sustainability, and he was saying that composites is definitely in scope for that. Okay, so perhaps one last question here from Jonathan Fuller. Good animation, nice work. Do you think the planned programme of work and its outputs will be enough to win over the skeptics?
Thanks, Jonathan. I think there'll always be skeptics. And who doesn't love a good academic debate? But our hope is that we can show impact, build credibility, and try and actually start things off. If we can coalesce the funding, make sure that actually the outputs of those funded projects have the greater good, I think we'll see a difference. And if we can get to that point, and through partnership collaboration, we'll actually see enough that might win over those skeptics.
Thank you very much for that and for your part in winning over the arguments. Thank you for your presentation. And now I would like to introduce our next speaker, Fraser Barnes. We'd like to share your screen. So we're delighted to have Fraser Barnes, who's Managing Director of ELG Carbon Fibre, who is a real pioneer and world leader in carbon fibre recycling. So very excited to hear what he's going to have to say on the subject. Over to you, Fraser.
Thank you very much. Thank you for the introduction. Good afternoon, everybody. Today I'm going to talk about some applications of recycled carbon fibres. We've heard over the last 2 days about the methods that are available to recycle, some of the challenges which exist in terms of recycling composite materials. Today I'd like to try and give some ideas to you about what is being done with recycled materials today. So just to give you some background to this, carbon fibre demand is expected to grow from 123,000 tonnes to 192,000 tonnes over the next 5 years. Those numbers are probably a bit aggressive, if not a lot aggressive, but nonetheless, we're an industry which has got a solid track record of growth. And in that growth, industrial applications not only account for about 70% of demand, but they account for about 85% of the growth that is forecast to occur. And the industrial applications of carbon fibre are in many ways quite different to the applications where the industry first started, where performance in terms of mechanical properties was absolutely paramount. In industrial applications, you have a little bit more flexibility, and that's one of the things I want to illustrate in this brief talk. Just to give you some other numbers, in that period, if the growth forecast was true, then the carbon fibre disposed of as post-industrial waste, so in other words, the waste that's generated during the manufacturing process, would produce nearly 10 million tonnes of CO2, consume 135 terajoules of primary energy, and consume 245 million litres of water. So that's the energy resource, that's the water resource, that's the CO2 that's generated from throwing away materials during the manufacturing process. So those are pretty big numbers, and that's the opportunity is out there to reuse the waste that we generate and to actually reduce that burden that we put onto the environment. Putting the carbon fibre industry in context with other materials, if you look at other structural materials and you look at the 2018 data, steel with around about, these are in thousands of tonnes, so steel with about 1.8 gigatons produced each year, 42% of the steel that's produced annually is made using recycled material. And at the end of life, 86% of steel, which has finished its service, is actually recycled and recovered back into new primary steel. And again, you see the trend for other structural materials here. The standout is that in the composites industry, we have virtually no demand being met by recycled material, and recycling, both post-industrial and post-consumer, is almost zero. So the composites industry, even though we're still relatively small compared with other industries, the fact that we actually leave a big environment, or we create and then we leave a big environmental footprint, this is something which OEMs and consumers think about. And it's really important for us as an industry to start to address this if we're going to really realize the optimistic growth that is always forecast for our industry. So what is recycled carbon fiber? Well, it's a material which has very similar properties as virgin carbon fiber. That's in terms of the fiber mechanical properties, but is definitely not the same as virgin carbon fiber. Steve Pickering showed a very good picture yesterday which illustrated what recycled fiber looks like. There's another one that you can see here. And recycled carbon fiber has got very, very different physical form. And one of the things we can say is that achieving the degree of alignment and the fiber volume fraction that you see with virgin carbon fiber products is extremely challenging. But one of the things I want to illustrate in this talk today is that in many cases, you don't need high degrees of alignment and high fiber volume fraction to have a very cost-effective, very useful material, which can bring both environmental and economic benefits. Talking about, just to illustrate environmental characteristics of material, this is looking at the embodied energy and the global warming potential in terms of either megajoules per kilo of material and CO2 generated per kilo of material. And then looking at this in terms of energy or global warming potential per unit strength. And you see that on this scale, recycled carbon fiber scores pretty heavily. It's a pretty good material in terms of its environmental characteristics. One point I'll make is that where weight isn't a factor, then steel is actually a good material from an environmental perspective. And this leads into, you've really got to understand what you're trying to achieve, and then you need to select the right material for the right application. So when something moves or needs to be moved, then weight can be very important in terms of having an economic and an environmental sound solution. But where things don't need to move, then maybe weight is less important. And from an environmental perspective, at least, you can use other materials and get an overall environmental benefit. So lots of things go into material selection. It's not just always about choosing the material with the lowest environmental footprint. It's not always about choosing the highest performance material. It's around really understanding what the requirements are and then using the right material for the right application. Again, just another way of looking at this, and this just illustrates the embodied energy of structural materials. And you can see on this that recycled carbon fiber has quite a good profile compared with other lightweight materials. And so it can be really helpful to us in terms of making lightweight structures which have got low environmental footprints. Of course, in this again depends on the application. So if you've got something where weight is absolutely critical to its in-service fuel burn, then you want to use the highest performance material that you can do. That's quite the right thing to do. But in other applications, weight won't be that so critical to in-service fuel burn or in-service energy profile. And there you can use materials with slightly less performance. What we're going to be talking about today is materials which are suited for two broad types. So coatings and compounds, which are thermoplastic mainly, but also some thermoset materials, and then composites. And these are either thermoset or thermoplastic composites. So these are the recycled carbon fiber products which are available today from several sources. And what I'd like to do now is to actually illustrate how these materials are used. So the opportunity space, first of all, these are just the properties of materials in terms of strength and stiffness. And you can see that recycled carbon fiber materials, laminates, so the composite type products fit in here. And then the recycled carbon fiber compounds fit in here. Why this is relevant is, many people talk about automotive as a target application for carbon fiber. In the automotive world, they're looking for a strength around 250 MPa and a stiffness between 35 and 40 GPa. And if they have a material with those characteristics, then that's something which they can actually make quite a lot of use of. It's a practical material to make a lot of automotive structures from. And you can see that the recycled carbon fiber materials cover that range. And so this just really illustrates that these materials are are quite adequate for a lot of applications in terms of the mechanical properties you get from them. They aren't the same mechanical properties as virgin carbon fibre, and we wouldn't want to pretend that they are, but they actually have adequate mechanical properties for many applications. And when you bring density into the equation, you see that in terms of the near competitors, again, they offer some density benefits compared with competitors in the same space. So why haven't these materials been used more widely? They've been available now for quite some time. Really, it comes down to lack of design data, the investment required to adapt existing processes, development time to optimize product forms for new application. A big one is industry conservatism, the lack of things to look on and say that's where it's been done before, so yes, we could do it. And then also the lack of standards, which are based on test methods appropriate to recycle carbon fiber. And this means there's a lot of development. This makes the development cycle quite long, which is a barrier to adoption. But what we want to show today is how some of those barriers have been addressed and show how several industries are actually now making use of these materials. So going into the first case study, this is a wind turbine nacelle. The original design had to use 400 GSM carbon fiber NCF in the nacelle construction. The company that, or the OEM has got particular reasons for this. There are very well thought through requirements for why it has to be a carbon fiber material. Initial testing, surprisingly enough, showed that the performance requirements could be met with a 275 GSM non-woven mat made from recycled fiber. And actually, further testing through the development program allowed that to be reduced to 230 GSM. So each ply of 400 gram non-crimp fabric made from virgin fiber is now replaced by one ply of 230 GSM non-woven, which is in a vacuum-assisted resin infusion process. This project went into series production towards the end of 2019, since when it's used 49 tons of recycled carbon fiber non-wovens. And these deliver a 16% weight reduction, a 57% material cost reduction, a surface layer is eliminated from the construction, and to date, 7 megajoules of energy and 291 tons of CO2 production have been avoided by using recycled materials instead of virgin materials. So this is a really good application, not an obvious application for the use of carbon fiber, but a good example of how we can start to reduce the footprint. Another example, we can't show you any nice photos of the finished part, but this is an automotive roof. The original design used aluminium for a low production car, fairly low production car. A laminate based on a 200 gram recycled carbon fiber non-woven, again, was found to produce the required mechanical performance. The formability of the non-wovens allowed the complex details required to make all of the parts required for the roof in a single tool to be easily produced in a fairly low cost manufacturing process. And the OEM involved in this program actually gave this an innovation award in 2019. Some of the benefits that which are delivered: a Class A surface finished from the tool, which is always a challenge for composite materials, a single tool used to make all parts, and that actually led to this being lower overall cost than the aluminium alternative, and lower environmental impact than aluminium, and a 10% weight reduction compared with the aluminium part. But again, that wasn't the driver here. The driver for this was purely around the economics. Another example is the Railbogie frame. Rail actually, there's quite a high value to weight saving in rail, not just to do with the lower operating cost because of reduced energy consumption, but mainly to do with reduced track wear due to lower weight, and also where you can tailor the stiffness of the structure, you get a reduced track wear due to increased lateral flexibility. This is a really conservative industry, at least as conservative as the aerospace industry. And so moving from composites to metals to composites for structural parts is very, very challenging. Alstom identified the bogie frame as being an area where they could make the biggest impact on a rail vehicle, and thought this would be a good demonstrator, because if you could show this could be done, then it would open up the door to using composites in many other structural applications within a rail vehicle. And so a project was established to investigate this further. A large amount of testing was done, as you'd expect. One of the big things we did was a very large fatigue testing program. And so we've tested all the materials that were being considered out to 10 to the 8 cycles in a simulation of a 30-year life in a railway environment. We obviously had to meet fire testing requirements, and so this ended up being based on an epoxy prepreg, which met the fire testing requirements for the rail industry. A lot of static mechanical property testing to get the design database for the FE analysis, and a lot of testing on the processing to optimize the process to make sure we had the right process to make the parts. So that all went in to support this program. And this is the resultant parts. This is a full-scale Railbogie. It will go onto a Class 180 vehicle. This is the bogie frame on the test rig at Huddersfield University. And hopefully any time in the next couple of weeks, we'll actually start the testing, which has been interrupted. We were due to start testing the first week of March, but as you can imagine, that's been somewhat delayed now. But a very good illustration of using, in this case, recycled carbon fiber with virgin carbon fiber to give a cost-effective, low-weight alternative to metals for a very complex structure. Another case study is an electric vehicle. This is for body panels and closures. The existing electric vehicle had to be stretched by 800 millimeters, and that required new carbon fiber roofs, side panels, and tailgates. Weight was actually very critical in this because of the modifications made to the vehicle. You needed the performance of carbon fiber in those parts, particularly the stiffness, in order to get satisfactory performance. And weight had to be kept below a certain level because of other restrictions on this vehicle. Again, extensive mechanical testing has been carried out to support the design. Parts were made again using autoclave cured prepreg, and recycled carbon fiber was also used for some of the tooling here. The benefits of using recycled carbon fiber material, apart from cost, the loft, drape, and stretch allowed the very complex geometries to be very easily formed. And again, that's been a common theme in using these type of materials. Again, the high quality surface finish on both the parts and the tools. And now this project has moved to phase 2, so going from prototype vehicle to pre-production vehicles, and these will actually go out for a more extensive on-road testing program. And this has been done by a specialty vehicles company, but the OEM has remained very closely involved in this project through its technical center. And there's an actual photo. These only came through today, so it's not in the presentation I've shared so far, but this is the actual vehicle, the prototype vehicle, about to start going out and doing on-road testing. One which a particular favorite of mine is the laptop cases. We always talk about rate capability of composites being a barrier. In this case, they make 6 million parts a year off about 30 fairly low-cost production cells. So composites can be used to make parts at very, very high rate, very, very efficiently. This project has been done with Dell. Dell's obviously happy for us to share the information. And they've rapidly evolved the use of carbon fiber from thermosets in their first cases in 2013, through introducing thermoplastics in 2015, overmolding in 2017, and now recycled carbon fiber introduced in 2019. The overmolding is very important. It delivers an 80% reduction in cycle time, a 20% increase in yield, and a 75% reduction in tooling costs for making these laptop cases. The recycled carbon fiber, as I said, was first introduced on a specialty model in 2019 and is now being used in mass production models. And again, Dell are using this in conjunction with virgin carbon fiber, a very novel combination which they're patenting at the moment. But the benefits compared with the previous carbon glass construction, 20% lighter, 15% stiffer, and against one of the alternatives, this is a number they quote, 80% lower greenhouse gas emissions compared to magnesium. So pretty big environmental saving, as well as delivering the consumer benefits of lighter weight. Another application, aircraft seating. So first generation full carbon fiber seat back met all the FST and HIC testing requirements and reduced weight by 20% compared with the existing seat back design. That is now line fit approved and flying with a major airline. Cost was a challenge, so the first version didn't meet the financial targets that were set. The next generation seat back is incorporating recycled carbon fiber and does meet the cost targets. Again, to give you some idea again, Actually, this will be a little bit more than 20% lighter now, so there's more scope for weight saving in the new design. Again, meets all FST and HIC test requirements and has a lower materials manufacturing and in-service environmental impact. So again, a good example of using recycled materials. And then finally, in terms of illustrating applications, I wanted to talk about compound and injection molding. For those of you who are old like me, we always used to look on the compound or injection molding as plastics, and we were composites, so we were obviously much better. But the development of injection molding technology, the development of materials, the design tools and the tooling which is available to injection molding means these is actually really a solution for composites today. At the simplest level, we use carbon fiber for its electrical or thermal properties in applications, electronic applications, mainly as illustrated top right. That uses about 3,000 tons of carbon fiber today, which could be substituted to recycled fiber straight away, delivering huge benefits. Small structural applications like the part you see there, the bracket in the middle, actually the performance of carbon fiber compounds enables that part to be replaced with an injection molded part. The big saving there again comes from tooling. The tooling cost saving in those parts is massive compared with the actual piece part cost. And then large structural applications. This is an example of something we're working on at the moment. Again, it relies on that sophisticated injection molding technology. And in this case, it's a injection molded carbon fiber part, which is replacing a magnesium casting. To put that into context, if that part goes into production, so actually a prototype has been manufactured, but each year that would save 320 gigajoules of energy production. It would save 375,000 tons of CO2 production applied to the 500,000 vehicles that are made annually. So what we can say is, cost-effective recycled carbon fiber combined with a high rate capability of injection molding creates a lot of new opportunities for carbon fiber composites. And these are the sort of things which could really drive those growth numbers that we all hear talked about in many conferences. I was going to show a video, but I think I'm just running out of time. This is available on the INEOS Team GB website, and it talks about their use of recycled carbon fiber and what they're doing with it. Again, another very interesting case study. And then to wrap up, what we can say is that carbon fiber recycling is established at an industrial scale, not just at ELG Carbon Fiber, but at several other companies globally as well. The materials offer a lower environmental footprint compared with other lightweight materials, and they're cost competitive used in the right applications. And I really want to stress this, using the right material in the right place is critical. There is no one material suits everything solution. You've really got to think about what the requirements are and pick the right material against those requirements. Industry conservatism has meant a long gestation time for the industry, but what we see now, as we've just illustrated, is a wide range of applications, and that range of applications is now increasing as industry confidence grows. Today, it's fair to say that our focus is on post-industrial waste, so the waste that comes out of manufacturing as uncured pre-preg or cured laminate trim. End-of-life waste brings new challenges in terms of waste separation and preparation. The same recycling material technologies will be applicable, but we do need to get our minds around the end-of-life waste challenge and how we deal with that. And that concludes the presentation. Thank you.
Thank you very much, Fraser. Time for a couple of questions. One here from Manindra Nath Roy. How many times can we recycle carbon fiber from composite?
Yeah, we don't know the answer to that. I think that one's come up a few times. We've certainly gone from recycled mat back into recovering fiber again, and then we can turn it into a chopped fiber, which can be used for injection molding. But we've done no real mechanical testing on the injection molding compounds. So we've demonstrated it. We've demonstrated it's feasible to do it from a physical process point of view, but we don't have data around materials that have been through multiple cycles.
That's something that our later speaker in Hamilton may touch on possibly, so we can perhaps pick that up again. Question from Ananda Roy at CPI. Can the manufacturing of recycled carbon fiber non-woven be extended towards recycled carbon fiber co-mingled with other thermoplastic fibers to make a non-woven mat?
Yeah, absolutely. So we co-mingle today with PEI, PPS, PA6, PP, and PET. So a lot of projects, so we didn't show any examples, but yeah, a lot of projects where the carbon fibre has been mingled with a thermoplastic fibre, made into a non-woven, and then press molded.
Do we know what the embodied energy is for recycled aluminium or steel?
Yes, we do. We did a study with Fraunhofer, which looked at both our process and the carbon fibre we were producing. So obviously from feedstock through to finished product. They looked at virgin fibre, and they looked at magnesium, titanium, nickel, steel, aluminium at the same time. So yeah, we have that study. I think we've shared that with quite a few people.
Okay, perhaps one last question here. In the application of the laptop case, does carbon fibre composite shield the signal or have other electromagnetic
actually, all of these. So the answer is I don't know the answer to that question. It might be performing a shielding function as well, but it's really there for the mechanical performance. So there's quite a stringent mechanical requirement around that laptop case because it holds the screen, and so stiffness is absolutely critical, and under various load cases as well. So it's largely there for the mechanical performance. Whether it performs a shielding function, I don't know.
Okay, well, thank you very much, Fraser. So
Okay, thank you very much.
Next speaker, which is Dr. Tia